This is the first lesson on lines of best fit, just using the singles means method. We're going to be looking at a few scatter plots and trying to find relationships between two variables. As it says here, a scatter plot is constructed from data that occurs in pairs. So you might ask someone how old they are and how much money they earn, and plotting those points onto a coordinate system. One variable is x and the other is y. So we might have something like age on the x-axis and hourly pay on the y-axis. And we might see that there's a positive relationship between how much someone gets paid and how old they are. Positive relationship, negative, no relationship, and negative relationship. So a positive relationship is one where as one variable increases, the other generally increases. So like this first example, as someone gets older, their wage generally goes up. There might be a few little outliers here where there's old people getting paid not much, but we're talking about just generally all the time. It might be that you find some data and you plot it and you find that there's just no relationship between the variables at all, such as could be your age and your favorite number. Okay. If you're older, it doesn't mean you're going to choose a bigger favorite number or anything like that. And there might be some instances where there's a negative relationship as well. For example, this could be the number of hours that you exercise per month, and this could be your weight. Okay, then just ignore the numbers for this scenario. So the more hours exercise you do per month, the less you'll weigh. Okay, so we can see those three examples. So in here, I'd like you to write a few examples of positive, negative, and no relationships. So typical ones for positive relationships would be something like age and weight. So generally, as we get older, we weigh more. You can think of a lot more positive relationships where one thing increases and the other one increases. Examples of some negative relationships. We could think about the temperature and the amount of clothes that people wear. As it gets hotter, people seem to wear less clothes. We might think of things like time and value of a car, for example, where if I put the value of the car on the y-axis and time on the x-axis, buy a car, the value's generally going to decrease. And we could just be plotting the market value of the car and finding a relationship between them. Examples of no relationship, could think of lots of things like age and number of avocados eaten. Or maybe the day of the week and the weather. Okay, all these sorts of things where there's just no relationship between the two variables. Okay, it just looks like a random collection of dots. Alright, so they're the three: positive, no, and negative relationship. What we're going to do is try and find a line of best fit for some data that may have a positive, negative, or no relationship. We're going to find the height and weight of students in 12 Maths A. This is real data from a 12 Maths A class. Okay, I'm not in class obviously, so we can't measure ourselves. We want to find the line of best fit for height and weight of the students. So we're going to draw something with height and weight and plot this data on here and see what it looks like and determine whether there's a positive or negative relationship. We'll draw a nice set of axes. You could have put weight and height the other way around, doesn't matter too much. And then we're just plotting these pairs of data. So a height of 153 and a weight of 45. I'll find where that point should be. About there. And then I'll plot all the other points exactly the same. Probably tick them as I plot them. So go ahead and plot all your points. Get a whole heap of points that look like this. Now it's my task to draw a line of best fit between them. This is generally a positive relationship. Here we can see that as someone's weight increases, their height, they tend to be taller as well. Okay, so what we're going to do is have a look at this thing called the one means method, or the one mean method rather. Okay, what we'll do to the height and to the weight, we're just going to calculate the mean of all this data. So we'll add it together and divide by how many there are. So the mean height is 172.22. The mean weight is 67.22 kilos. And what I do is, to find the line of best fit, instead of just putting my ruler on it and guessing where the line is, I'm going to let this point help me out a little bit. So I'll find where 172 and 67 is. It's about here. I need to just make sure that my line of best fit passes through that point. So my line of best fit could be any of these lines, okay, as long as they pass through that point. Obviously, I'm not going to choose either of those points. I get my ruler out, try and make sure that I have an even number of points roughly either side of this red dot, and I go ahead and draw a line of best fit passing through that point. Okay, so obviously you can do it better because you have paper. That's roughly what my line of best fit would look like using the one mean method. Okay, remember this point gets plotted here, and then we use that to find the line of best fit. Let's see if I can answer the question 2. So use this to predict the weight of a student who is 160 centimeters tall. So all I need to do is, for part B, question 2 rather, read off 160 and then read down to where this weight is. So if someone's 160 centimeters tall, predicting that they'll weigh about 43 kilograms. So roughly 43 kilograms, reading off the graph. And the final question, use this to predict the height of a student who weighs 300 kilograms. Well, to find that, I would have to extend this graph out to where 300 is, and then read off wherever it is, okay? Didn't draw my scale big enough to do that, and in the next lesson, we're going to look at how we can find the equation of this line, so that we can then substitute in any value, like 300 kilos, to find how tall they would be. Okay, so for this one, need to draw a bigger graph. And I probably should have looked at the question before I drew my graph. Alright, so from here, have a go at those questions in exercise 13.3. Good luck.